I'm in Visual Studio, and we're taking a look at some C# code. This code is part of the demonstration we'll run in a few minutes to help us understand the performance implications of using bind variables. This is a simple data access method that takes in two parameters, a student ID and a term code, and it's going to return a list of course grade objects, which is just an object that encapsulates all of the grade data inside of it. Looking at lines 23 through 25, we see the text of our SQL statement, and notice that the where clause, we aren't specifying the student ID or the term directly, but we do see our bind variables. Then, as we move down and look at lines 28 through 31, this is where we set the values of our bind variables. On our Oracle command object, there's a parameters collection, and what we'll do is we're going to new up two Oracle parameter objects. Those objects are going to contain the name of our bind variable and of the value, and then we're going to add those objects to that parameters collection on the Oracle command object. At a minimum, you need to specify the name and the value in the Oracle parameter object. There are other items that are available though for you to set, and these include things like the data type and the size and precision for numeric values. If you want to go ahead and set those, you can access them either through some overloads on the constructor or through some properties. So let's go ahead and set a data type right now. So student ID parameter, we actually want to use the Oracle DB type property, and this is an integer in our database. So there we go. There are a couple of other things that you should know about using bind variables in your application. First of all, you need to add an Oracle parameter object to the parameters collection on the command for every bind variable that is defined in your SQL statement. If you forget one, your program will throw an exception when it's run, and the message you'll get will be something along the lines of insufficient values to bind into your statement. Second, you need to add the parameters to the parameter collection in the same order that they are listed in your SQL statement. That is, when Oracle matches the parameters up with the SQL statement, it actually does so positionally. It's not looking at the names. So if I were to go ahead and reverse the order here, and I'll do that right now, I'm going to put term code first. This code here actually would throw an exception. Now there is a parameter that you can set on the Oracle command that says, I don't want to bind by position, I want to bind by name. And the name of that parameter is bind by name, and you just simply set this property to true, and then this code will be okay. Oracle will match these up by their name and disregard the position, and this code will run just fine. I realize this is C# code, and not everyone is a C# developer, but generally speaking, things are going to work in a very similar fashion in all languages. In Java, what you'll want to do is you'll want to use the prepared statement class, and on the prepared statement class, there are going to be methods to add parameters onto that object. In other languages, consult your documentation for how to add parameters into your SQL statement, but generally it's going to look something like what we have here. I want to take a moment to contrast this code with some data access code that uses literal values. So I'm going to jump over to the other class called literal values DAO. This is the same method as we had before, where again we're passing in a student ID and a term code, and you'll see that the major differences are in the SQL statement that's defined on lines 25 through 27. Here, we're inserting the values passed in directly into our SQL statement using string concatenation. And then it's this SQL with the literal values included that's being submitted to Oracle each time. You can clearly see here that as we pass in different parameters to this method, then we would create a different SQL string and submit this SQL string to Oracle each time. There are a couple of problems here. The first issue is that, as we've talked about in this module, each one of these SQL statements is distinct and ultimately going to result in a hard parse up in our Oracle database. The second problem, though, is that anytime we are forming up SQL using string concatenation and inserting values passed into us directly into our SQL, we're vulnerable to SQL injection attacks. When we use bind variables, the Oracle driver will automatically escape any special characters that are in the value that's passed in, so our SQL statement is protected against any values that were submitted with malicious intent. With literal values, though, that string is just passed on through to the database, and this poses a very serious security threat. Now, using bind variables doesn't mean that you shouldn't implement other good security practices like validating your input in your application, but they do offer one more level of protection. There are a couple of final items that we need to cover. First, pretty much all of the major object relational mappers in use today already use bind variables implicitly. So if you are using Entity Framework or in Hibernate, your application is already using bind variables and you should be in good shape. If you are using an ORM, you might be tempted to think that bind variables is a topic you don't need to worry about. However, while new development might be taking place using an ORM, a lot of times we have to support existing applications in our jobs. And you want to make sure that these applications that are just using plain old ADO.NET or JDBC are using bind variables as well. And if they're not, you want to get those applications uplifted. One reason why that we just covered is the security concerns around SQL injection attacks. The other reason is that if you have one or two of these applications out there in your organization, these applications by themselves can use up a lot of resources on your Oracle server and cause contention around the shared SQL area. So in that way, these existing applications that don't use good practices can impact the performance of all of your other applications that are using that same Oracle instance.